Well, hello, everybody. Welcome into the Great Atmosphere Show. My name is Zach Elsom. I am a consulting meteorologist for a U.S.-based firm here. I am based out of Charlotte, North Carolina. Graduated from the UNC Charlotte School of Meteorology, and I have worked previously with the National Weather Service in Columbia and AccuWeather up in State College, Pennsylvania. The purpose of Great Atmosphere is essentially I just want to do it for fun. Synoptic-based forecasting discussions are not something that is typical for me. In my day-to-day, I'm more climatological and data-oriented in my everyday work life. So I'd like to keep those skills sharp and also have an avenue to provide some synoptic and mesoscale-based weather discussions for friends, family, whoever else is in the greater Southeast region that might necessitate a video or two for any weather system that might be coming down the way. So, and coincidentally, actually not coincidentally at all, it's very much on purpose, we have ourselves a little bit of a weather system that we have to talk about today. But first, we're going to take a look at some of the goings-on in the greater United States of America. Currently, we have a cold front that is coming down from the northeast, down from the Great Lakes and into the Appalachian Mountain region. We see earlier this morning, we saw pretty easy to locate gravity waves, which is an indicator of cold air aloft that's trying to mix in with warmer air at the surface. So we saw that this morning. We also see a continuation of some deep valley fog here in the Ozarks into the Tennessee River Valley into the Mississippi, pretty much through the whole of Tennessee and the Huntsville, Alabama, northern Mississippi region. But generally cold air and high pressure building in is the dominant story going into it for the southeast. You can see this looking on the WPC's current weather map. That high pressure is building, and it's building in pretty quickly as the cold front slowly meanders its way off of the mid-Atlantic coast. Now we're going to move forward in time to see what the issue is at hand. We have a low-pressure center that it's a cutoff upper low that is currently centered over the Four Corners region of Arizona, Colorado, Mexico, and Utah. Little known fact I learned relatively recently is that Santa Fe, New Mexico is the highest elevation state capital in the United States. You wouldn't think that, considering it's New Mexico. You think south, but actually it's pretty well situated in the Rocky Mountain range up there in the north. So that's why predominantly most of the northern part of New Mexico is experiencing some pretty heavy snow today. This system is ultimately going to make its way into the southern central plains and going to make for a heck of a weekend for the mid-Atlantic coast and the northeast and parts of the southeast as well. So we're going to move forward in time. You see that high pressure is building, and it's going to open up to some pretty nice weather here, some clear skies. It'll be cold, it'll be frigid for the next couple of days, but ultimately it'll be a pretty nice one. No, not a cloud in the sky for the most part. But as we move forward in time, we see this low continues to move forward. We have a little bit of severe weather that might come into the region here in the Bayou region of New Orleans and lower Mississippi, Alabama, deep south regions before we move into the weekend. And as you can see, we got heavy snow, we got light snow, we got freezing rain, we got sleet, we got ice, we got predominantly heavy rain. We got a little bit of everything, and that is very common here in the southeast. But you can see that the main indicator that we're seeing here is ice. So let's move forward and see what else we got going on currently. Radar-wise, we have that cold front moving in. Windward slopes of the Adirondacks, Poconos, and Catskills are experiencing some light snow showers, as you do when a cold front comes off the lake. We also see some mild lake effect snow up near Sault Ste. Marie and the UP in Michigan. Then we also have our system here that is brewing here in the Four Corners. We see those snow showers and some snow moving into the El Paso region of Texas. Moving forward, though, we can see some of our temperatures that we currently are experiencing. We got mid-40s now across most of the southeast, some mid-50s, and we're struggling to get out of the 30s here when we get up into the DC metro area. And then, of course, probably one of our big problem areas we're going to be talking about, we are still under the freezing mark when we get into southern West Virginia and the western parts of the panhandle of Virginia. Looking at our water vapor imagery that we have right now, this represents the cold, or not the cold, the dry or moist air that is currently visible. Got to refresh this page so we can maybe see it. Doesn't look like the refresh is currently happening, but it's still a pretty good representative of the dry air that's currently in place. Yellow, orange values represent dry air, and bluer, whites, and greens will represent very moist air. So we see that pretty well represented in the Four Corners region and the Pacific Northwest, and not so much in the Southeast as of right now. Moving forward, we're going to take a look at what the Euro has to say in terms of what we're expecting for the next 72 hours. We see that low center starts to move and then dip a little bit further south before coming up. This is generally referred to as a Miller Type B storm, where we have the low moving down off the Rockies, reforming in central Texas, dipping even further low, just kind of grazing the Gulf of Mexico before ripping underneath the northern Georgia end of the Appalachian Mountains up across into the mid-Atlantic before bombing out on the 4070 latitude-longitude line intersection, which is about 50 miles south of Cape Cod, Martha's Vineyard, that general region. And that is a general well-known northeastern indicator for a big nor'easter storm, which is where we can generate quite significant snowfall totals if everything lines up correctly. So what we're looking at next is kind of where we've been this week, and it's been a very interesting forecast to try to get a handle on, just because there has been very little model agreement pretty much leading up to the 48-hour out mark that we're at right now. This is currently where we're at looking at the GFS. You can see there's not zonal flow, which would be horizontal lines going across the page, but they're generally equidistant to each other, just little short waves that you see in the middle in between of these isobars. And this is looking at 500 millibars, so pretty high up in the sky, in the mid-levels, as meteorologists will say. But we see the majority of the forcing that we're expecting with the storm to kind of just be oriented in these little short waves. That was not the case earlier in the week. Earlier in the week, we had this monstrosity that was currently going through, and this is all predicted at the same time. This is about, what is this, 12Z? So this is about 7 a.m. on Saturday morning. As different model runs came out earlier in the week, you could see that there is a much more significant forcing that's currently available, that was available in the Mississippi River Valley. And when you see these, it's called diffluent flow, and when you see these lines start to separate as they come out of a high vorticity area like this, that's where you get a significant amount of what's called diffluence. That leads to rising motion in the atmosphere, and you get higher convection, which means that the storm system can lift a whole lot more a whole lot more moisture up into the atmosphere, which can then condensate and precipitate down onto wherever it might be. So we were thinking that whatever was going to come, it was going to be a pretty significant precipitation event earlier in the week, but then we shift forward through time, and all of a sudden that big wave becomes little minute short waves. Which is why for this storm system that's coming here on early Saturday morning, we are not expecting a huge deal at all in the southeastern U.S. Going to move on, and this is another representation of that vorticity, which essentially is just strength of storm, I think is the best way to put it. It's generally measured in that 500 millibar region, and it emulates the spin, the convection, the ultimate strength of a storm system as it moves into the region. And you can see that pinch, that elongated troughing that was present over Mississippi is no longer generally there, and is mainly currently represented still with some elements of vorticity throughout, but they're smaller. They're in those short waves, and they're ultimately not as powerful. Now, this is generally not very common. Usually the models are much better about this kind of thing. The two main flagship models, the ECMWF, are colloquially known as the Euro, and the GFS American flagship model are the two main global models that we typically use as forecasters to be able to see things from a relatively far out distance, usually about 10 down to whenever the actual event occurs, but there's better options as we get closer. Generally, we'll say like the 10 to 5 days out kind of is the best way to use these models. They haven't been great. Well, I'll say the GFS has not been great. The GFS here is represented by the red. The 9.9 represents 90th percentile of accuracy, which is the benchmark goal for these global models, and is still very, very good. But you can see for the majority of this starts in mid-fall, that the GFS periodically, and this is generally when big storm systems occur, does not meet that 90th percentile benchmark quite consistently, except on days where it is nice and clear for the most part. So we would expect, and especially now that the GFS is performing in the 82nd percentile, we are not expecting very good things from the GFS. So for the remainder of the video, and we're going to be focusing mainly on things that are either from the Euro or other models or convectively allowing models that are closer to the event and better to use anyway. But generally speaking, this is what happens a lot in meteorology. Sometimes the global models, or other models in particular, do particularly well about predicting a certain storm, and some don't. And you have to kind of use your forecasting knowledge to be able to discern who's doing the best at representing the system as it's occurring in observations in real time. At the moment, the GFS is not doing well, so we are not going to pay attention to the GFS right now. In a week or so, 2 weeks, who knows? It could be great. But in this current scenario, it's not doing great. The Euro, on average, is not doing as good as it's normally been doing, but it is at that 90th percentile still, so we'll still respect it. So when we come to winter storm formation, we are looking for primarily three main things in the southern tier of the U.S. where we would get a significant snowstorm. I'm not advocating for a significant snowstorm. You're not supposed to as a meteorologist, but there's a snout, or what is lovingly referred to as a snow drought or a snout, across much of the mid-Atlantic, going all the way up to, I believe, Boston has not even had an inch of snow for 2 years. So there's kind of a hankering, I guess, in the mid-Atlantic or East Coast, Eastern Seaboard region for some big snowstorm. In this scenario, we need strength of storm. We need, which we already talked about with the vorticity. We need adequate temperature advection, which means we need cold air in place. Obviously, we need cold air for snow to form, and then we also need the moisture in place, so there's actual rain or snow to be able to turn into snow in the atmosphere. So we're going to take a look now at where I believe, yes, so this is 700 millibar level. This is what is referred to as the low-level jet. Low-level jet is the primary moisture transporter for the southeastern tier of the United States. So essentially what we're seeing here is we're seeing not necessarily we don't need to look at the temperatures. We need to see where the wind is coming from. And as we can see here, the majority of the wind that we're experiencing here in the mid-Atlantic states, so as Virginia, North Carolina, South Carolina, is coming from the southwest, which, if you look towards the southwest, where's that? That's the Gulf of Mexico, and the Gulf of Mexico is an exceptionally warm area to be in. And not only that, is full of moisture. So we're kind of, we're not going to take a look at temperature at this level because it's not necessarily that important temperature-wise at the moment. But from a moisture standpoint, that's very important. So it shows that we definitely have the moisture in place, and we can see that actually reflected in the PWATS, which is the precipitable water available in a typical temperature profile. We're going to move forward in time to, I believe this is Saturday morning. A little bit further back, we got a little too far. If we look at Saturday morning here, yes, so we see PWATS coming back quite significantly. We're getting into that inch range, an inch of precipitable water. I can't remember the exact measurement. It's some inch per cubic meter in the atmosphere or something like that. Not entirely sure, but all I know is that once we get over an inch in particularly cold environment, that is generally speaking a good opportunity for precipitation, no matter what form it may take. Taking a look now at temperature, we're looking at temperature at the surface, which is the most important temperature for what we're going to see precipitation-wise at the surface. We see actually that there is a little bit, we're going to move forward. Yeah, this is Saturday at around 6 a.m. We see, generally speaking, a lot of stagnant air in this area. But you can see, though, that there is kind of like this little dip of blue. And then onto the west, on the other side of the Appalachians, it's green. So there's about a 10% or a 10-degree difference, generally speaking. And these are current observations, so I'll try to get rid of those if I can. Doesn't look like I can. So ignore the observations, but look at the overall the colors, and you can see that this is a cold air damming event. When cold air is being advected from the cold Atlantic or the north, and it can't escape anywhere, so it gets dammed up against these mountain ranges here in the Appalachians, and ultimately, as cold air sinks, the lower regions of the atmosphere will be colder than the upper regions. So things that might normally fall as rain all the way through the profile of the atmosphere will get to the surface, and depending on how deep that cold layer is at the bottom is where is determines what kind of precipitation it'll be. So if it's cold the entire way down, it'll be snow. If it's warm at the top and then mid-level down, it turns into cold, then it'll freeze as it comes all the way down into sleet, and so on and so forth, until you get down to, if it's just a very thin layer of cold air at the very bottom, it'll come down fully as rain, but then because it's so cold at the surface, it will freeze, and that's where we get freezing rain. That is the primary threat that we're going to be talking about here coming up right now. So these models that we are looking at now are lovingly referred to as the plumes, the SREF plumes, the short-range ensemble forecast plumes. So essentially what this is it's a measurement tool to forecast confidence on what type of precipitation that 153 models that are currently are always running are predicting for certain locations throughout the United States. So if we go here, and this is particularly forecasting precipitation type. Right now we're going to look at Roanoke, Virginia, which is the largest metropolitan region that is currently under the gun for a freezing rain event, and you can see why. Because starting here at about, 9Z, starting here at about 9Z is when we start to get a higher chance of freezing rain, and that freezing rain percentage goes all the way up to 72 until about 15Z. 15Z is about 10 in the morning. And then as you go down, and this is just the highest precipitation type, so we would expect whatever falls is expected to be freezing rain in this vicinity. And then after that we have green, which represents rain, and this is very common because freezing rain from a physical point of view is a self-limiting precipitation type, because as water freezes, it is pushing out heat from the ice that it is currently creating to create ice, right? So that heat has to go somewhere, and as it freezes, the heat goes into the atmosphere, ultimately warming it up, and thus melting the ice. So you can see that if it's just freezing rain that happens, it's almost certainly quickly followed behind by rain, and which was going to be reflected in a lot of these. So we're going to look around at other places. You see Asheville, same exact deal. We got freezing rain to start, followed quickly after by rain. We're going to move into, let's see what Boone's looking at. Boone, same exact deal. We're going to move into Hickory, which I believe is right on that rain-snow line. Oh, it's very close, but freezing rain immediately over into rain. That looks a lot earlier in the day, probably around 7 or 8 a.m. on Saturday. And then we'll take a look at Charlotte at the airport. It's predicting just straight rain from this point of view. Winston-Salem, same deal. And this is not necessarily, this is an ensemble point of view. It's generally what the models are all agreeing on. It's not necessarily reflective of what will happen, but this is generally what we're expecting. It's a freezing rain to rain event for the majority of the forecasting region. And we can take a look at some other stuff. This is the freezing rain and mixed precipitation estimation provided by the Euro, or the FRAM as it's referred to. And this is what they're currently looking at for totals. This is about 0.2 inches of ice for the Roanoke region. Now that is quite significant, because even you're just 0.1 inch of ice doesn't seem that much, but 0.1 inch of ice is about 300 pounds on a power line. So it's quite significant in terms of what it can do. And these are general estimations in terms of, like, this is not a pinpoint forecast, is what I'm saying. The resolution for the ECMWF model is, I believe, 9 kilometers. So you're looking at 9 kilometer grid blocks that you're looking at here. So it's not necessarily going to be very accurate. It's a good way to get an understanding of what is generally expected on a regional level. So this is something that I think a lot of forecasters are looking at, actually. This is the NAM 3 kilometers, so a much more accurate resolution for the region. The NAM is almost famously much better at predicting winter precipitation than any of the other global models. It is not technically a global model. It is, I believe it's on the same level as the rapid refresh model for those who understand the nuances about that. It's like an in-between. It's not a convectively allowing, but it's not a global model, but it is 3 kilometers. Not exactly sure what to refer to it now that it's 3 kilometers. I'll have to look that up after this. Anyway, the NAM is seeing much higher values of ice stretching a little bit further inland into the Piedmont, and in addition to that, higher values of ice in the regions that are predicted into that Roanoke Smith Mountain Lake region, and also down across the Blue Ridge Parkway. And I can almost guarantee you that everyone, and this is what precipitated the quite early winter storm watches that GSP, or the Greenville-Spartanburg Weather Forecasting Office of the National Weather Service, put out, which kind of a little bit of a minor controversy this morning, because even though Roanoke and areas in Virginia and that region up north, they have a higher chance of ice, they did not put out a winter storm watch, or a winter storm watch like this morning. Only GSP did for the mountains of North Carolina, which are not going to be receiving, nearly as much of a problem, hopefully, as Virginia. And I would assume, and I read their forecasting discussion this morning, and it is true that they saw the NAM that we just saw and said, that's a problem. We're going to have to address that, because there is they are believing that this area can get up to almost a quarter of an inch of ice in some areas, with 0.3 inches locally. So they're quite bullish on this icing scenario even further south, which I can only assume, if they were responsible for forecasting Virginia, that it would be a much, much worse event if they were in charge of that. However, in Blacksburg, where the weather forecasting office is for the RVA region in Virginia, they don't have that same amount of confidence that it's going to be that severe. So this is kind of the problem with having a diverse range of forecasting offices. It's obviously great for the locals, but on a regional level, it can be a little bit confusing. So taking a look at just what they're looking at here, and the Blue Ridge Parkway and the National Park Service generally does a good job of reflecting whatever the National Weather Service is expecting. Pretty much right on cue, they close down the Blue Ridge Parkway, but Virginia still has their areas of the parkway open. So that kind of shows kind of the consequences of where these watches come into play. And this is a final weather prediction, forecasting, probabilistic winter precipitation guidance map of what the National Weather Service, the ones that are based out in Norman, Oklahoma, what they're predicting on a regional scale. They're saying that the main center will be due southwest of Roanoke. I believe that's the Pulaski region. Franklin County is down here. I know that. Rocky Mount, that region right there. They're going to be under the gun for quite a significant snowstorm, or icing, I'll say. That's the probability. We're at about an 80-ish, 90% probability of receiving 1/10 of an inch of ice. That's pretty slam dunk right there. We're going to look at what 1/4 of an inch looks like. Quite a bit lower. We're at 30 to 20% according to the WPC. So it's just all good stuff to know. And then we're going to look at, this is one of the most underrated things, I think, of forecasting snow in the southeast, and it's soil temperature. So this is a estimation of what the soil temperature is 4 inches down into the earth on average. And what we are looking at here is we can see this line that denotes between the green and the blue. That represents ground that is frozen. So naturally, anything frozen that falls on it is going to remain there and be frozen for a while. And that's particularly important for ice, because the only way to keep ice from not heating itself to death and melting is if cold, dry air continues to replace it. That necessarily will not be in place in the long term, but in the short term, the soil moisture, or the soil temperature, is very important on maintaining that ice. So as this is currently, this is at noon Saturday, and you can see why we have such great accumulations expected for this particular region, and why roads might be an issue as well, is because that blue-green line dips all the way further down into the Asheville, North Carolina region, and definitely is sinking as far south as Southwest Virginia. So that is a significant factor going into this. So that's currently what we're looking at. It looks like a pretty significant ice storm event generally speaking. I mean, for the past few years, we've had next to nothing in the southeast. So this is the first sign of something. Looking at the climatological overall pattern, I can tell you that this is not going to be the only one. We actually have another system that is on the way. We can see that actually coming in on the radar right now, currently in the Pacific Northwest. That'll be a whole nother can of worms. It'll be mainly a Midwestern, Northeastern system, but it'll be a quite significant one for them. And then there might even be one after that, which will give us a little bit of a give us a little bit more of a hankering for some wintry stuff coming down the pipe, probably in about 2 weeks' time. So lots to talk about coming up. Generally speaking, though, and I did want to end on this little fun thing. This is the experimental GraphCast sponsored by the Euro, but run by Google DeepMind machine learning analytics. And essentially what they're doing is they're creating an AI tool which can learn from all the current and past precipitation analyses and create their own forecast for total accumulated precipitation. And as we can see here going into next week, this is Tuesday. We can see a little bit of stuff going on in the Louisiana Deep South. Keep going up here. Yes. These are deep reds that represent over 3.5 inches of rain. Or precipitation in general, but we know it's going to be rain. We're going to have severe events down in the south. We're going to have flooding in the southeast. We're going to have blizzard conditions. Maybe not blizzard, but definitely feet of snow is definitely in the cards for New England. And then we'll have the Midwest will obviously have a big wintry deal as well. Will be quite the week, middle of the week next week. And it'll be fun to take a look at that with you. So I appreciate y'all tuning in. Once again, my name is Zach for Great Atmosphere. I hope you have a great rest of your day, and we'll see you next time. Bye-bye.